I'm sorry, Genstruct. We have Genstruct. And they are going to be talking about their Detroit record sales industrial complex. Thank you. They're going to give me a minute to get seated.
Good afternoon. Once again, we are Genstruct Engineering. My name is Ryan Bwaszek. I am the team leader and the construction engineer. To my left, we have Zachary Weber, our transportation engineer. To my right, we have Ashley Norbert, our structural engineer, Aaron Deaton, our geotechnical engineer, and Jonathan Andre, our water resources engineer. We're presenting to you today on our Detroit Wrecker Industrial Complex. This is an isometric model that Ashley will go over in detail in a little bit. But first, who is Detroit Wrecker Sales? Detroit Wrecker Sales is a locally based business founded in 1986 in Detroit. They specialize in high-end wrecking equipment. They have two proprietary lines. Their first line is Little Hercules. This is an industry first as it mounts under the bed and does not require any items in the bed to use the equipment. The second item is their low loader. This is a very low angle load system that allows high-end cars to be loaded without damaging them. So what is the problem? Detroit Wrecker Sales is currently overbooked with orders and is unable to fulfill these orders and needs a larger facility in order to complete orders they have in the system now. Additionally, they want to expand their product line. This was unveiled in February this year. This is the Gladiator, and it's the third proprietary line that they would like to put into development but cannot due to restrictions on the size of their facility. Our project location is in the northwest portion of Detroit, across from the existing Detroit Wrecker facility. As you can tell in the bottom corner here, the existing facility is right here, and we're proposing to take Granville Avenue between Schoolcraft and West Davison for the site. Our proposed site layout puts the building on the east side with parking lots and the test track facility on the west side. And now I'll pass it to Ashley for the architectural and the structural engineering.
Thank you, Ryan. The first part of the structural part of the building was to design the building. The design was developed using Revit 2014. The team decided to make the building 69,600 square feet. The first story, which is the manufacturing with some locker rooms and the display area, is 57,000 square feet and it's 30 feet tall. The second story is directly above the locker room and the display area, and it has some initial offices and the break room. The third story is 7,200 square feet. It spans the entire south end of the building, and it is the structural engineering part of the structural scope of this project was to calculate the loads, design the RISA models, perform the structural, determine the steel member selections, design connection designs, the connection details, and the floor and roof systems. The load calculations were performed using ASCE 7-10. Snow was determined to be 20 PSF. The maximum snow drift from the third story to the manufacturing building was 40.6 PSF. The live load varies throughout the building depending on the room, as shown in the figure to your right. And the maximum wind load occurs on the west side of the building with a wind load of 19.4 PSF. The green roof is an additional dead load added to the building covering most of the manufacturing is 35 PSF. The floor and roof systems were developed using Volcraft steel and roof deck system catalog. The floor systems were designed with the same assumptions for load criteria, so the same composite floor system design with 4.5 inches of lightweight concrete and a 1.5 BL22 deck size. The 3-story and the manufacturing roofs have slightly different loading criteria, so therefore they have 2 different roof decks. RISA was done to analyze the structural aspects of the building. Some of the key features of the structural part of the building are the carrying trusses, which are located every 20 feet, spanning in the east-west direction. The jack trusses, which span in the north-south direction, are located 40 feet apart. The X bracing, which is along the east and west sides of the building, and the chevron bracing, which is in the three-story part on every floor of the three-story area. Once again, the truss system, the carrying truss, is a Warren-style truss. It is 6.5 feet deep and 40 feet long. It has purlin spacings of 6 feet 8 inches because of the geometry of the truss. The cords are WTs and the web members are double angles. The jack truss is this similar design, however, it's the web vertical spacing is 5 feet, but it also is 6.5 feet deep and 40 feet long. X bracing was used as a lateral force resisting system to help with the wind loads applied to the building, along with wind columns. Here's to your right is an example member sizes for the X bracing. Inverse chevrons were used in the three-story area also for lateral force resisting system, and those are some sample sizes for those. Connection design was one of the last things that I had to perform. There was 5 that I calculated. They include truss, shear tap, extended shear tap, X bracing, and the base plate connections. These are the final designs for the X brace and the shear tab. Now I'll pass off to Aaron for geotechnical.
Thank you, Ashley. As the geotechnical engineer, my main focus has been the foundation design for the building after determining a design soil profile for the entire site. I will also be discussing some of the key scope items that I have completed. My research began with the consulting of the Michigan Coordinary Map to identify the geologic conditions of the local region. Our site in particular features predominantly lacustrine type soils, which results in compressible clays. These softer clays comprise the majority of our soil design profile. At the top of the profile, we have a layer of silty sand. The groundwater table is at a depth of about 6 feet, and at a depth of 51 feet, we encounter the hard pan. The minimum shallow foundation requirements place the footing in the silty sand layer 2 feet above the water table. This allows a allowable bearing capacity of 1,500 pounds per square foot. However, there is over an inch in sediment, so this type of foundation is not suitable. The selected foundation type for our project is the drilled shaft with a belled end. The total length of the foundation is 52 feet to extend and terminate in the hard pan. This graph is a depiction of the allowable load capacity of one foundation as a function of the length of the shaft, or the length of the foundation and the diameter of the shaft with a constant fixed bell size. The target depth is at least 51 feet to reach the hard silty clay layer. There is not much contribution to the overall capacity based on the shaft diameter, so 2 feet is selected in order to minimize cost. This graph, on the other hand, is a similar graph. It shows a constant shaft diameter with a varying bell diameter, and that allows a much greater influence on the allowable load capacity of the foundation. If we have a 52-foot length foundation and a 5.5-foot diameter bell, that allows our foundation to reach the maximum column load. The performance area for the complex is one of the major components. It allows Detroit Wrecker Sales to test their products on site. One feature of this performance area is a ramp that leads to a flat pit to allow for a towing scenario. The section at GG shows a 2-foot elevation drop at the pit and a gravity wall retaining system. The truck pulls up to the top of the wall and lowers its bed into the pit and can retrieve the vehicle from inside. The earth is subjected to a live load from the truck, and the gravity walls were designed with a Rankine analysis for active pressure. And now I will hand it off to John to talk about water resources.
Thank you, Aaron. Scope of work for the water resources for the project was to analyze the stormwater removal from the site. It began by gathering the required design documents. From there, the stormwater management plan was developed, taking into account both the environmental and sustainability considerations of the plan. Finally, the discharge water quality from inside the building was assessed. The design documents that were used for this first were the Wayne County Stormwater Management Program, and followed by the Green Infrastructure Plan for the Upper Rouge Tunnel area, and finally the Low Impact Development Manual for Michigan. Performance standards for the stormwater management plan are broken into two criteria to address environmental impact as well as stormwater runoff. The water resources protection is based on an 80% removal of suspended solids from the first flush of all rain events, first flush being the first half inch that occurs. This removal will happen through capture in the bioretention cells as well as inlets at the pretreatment inlets. Flood protection will occur through detention of 90% storm events. This is the time occurrence, 90% of all storms we can expect to detain on site that are 1 inch or less. 2-year, 24-hour, and 10-year events will be a combination of detention with metered retention. Catchment areas were first defined through StormCAD upon inputs from the completed site layout that we had. The catchment areas, when we're modeled, StormCAD, one of the limitations is we weren't able to model low impact development features. So what you see, catchment 1 is the entire roof area of the building. Catchments 3, 4, 6, and 7 compose the parking lots, with catchment 5 being all of Granville Avenue. Catchment 2 was left to drain to the earth as it's an impervious structure. The pipe layout is for a 12-inch concrete circle pipe underground. The arrows dictate the direction of water flow within the pipes. We being Bentley StormCAD, uses the rational method, which is required by Wayne County to calculate the runoff into all the catch basins, which are shown in pink here. The yellow circles indicate overflows from the low impact development features. Pipe profiles were generated from Bentley StormCAD, and it was required that we have 2.5 feet of vertical clearance to the structure rim on the furthest structure from the outlet, which is shown here. Water protection is going to occur on Granville Avenue with 2 features. There's a 3,000-foot rain garden out front of the building, as well as a 3,400-foot grass-lined channel to promote infiltration and capture the first flush along Granville. The green roof, once it was able to be put in, is our biggest low-impact development feature. It's over 1 acre in size. It's 2.5 inches planted with sedum. It is going to retain 41,000 plus gallons. The important feature of this is it'll provide our client $9,000 a year in savings for the Detroit Water and Sewage Department. We installed a capture and reuse system on the southern portion of the roof. It was designed from concept using a 20-year analysis of the urban green stormwater calculator to provide $800 in yearly savings on the water and sewer combined. It's a 2,000-gallon spiral reinforced polyethylene tank that can be buried underground for best management practice. I'd like to invite Zach the discharge water quality is going to be the last thing. Inside the building, we have 2 connection points. And the National Pollutant Discharge Elimination System regulations are covered under the Green Infrastructure Plan. And it is further known that we will not be known as a significant industrial user by the Water and Sewerage Department. So we will not require additional regulations for discharge water quality within the building. Now I'd like to ask Zach to speak about the transportation engineer.
Thank you, John. The transportation scope can actually be broken down into 5 key components, that being traffic analysis, safety analysis, the Westwood intersection, paving design, and the site layout. Of these 5 key points, they actually can be broken down into 2 components, one being actually of the surrounding streets, and the second being of the site itself. So starting with the surrounding streets, I gathered the existing traffic data, then projected a 20-year traffic count projection with the impactment of the facility. With that, I was then able to calculate the level of service for all the surrounding streets and of Granville. As you can see here, everything stays level service A, except for Schoolcraft, which drops 1 from level service C to level service D. During the safety analysis of the surrounding streets, it became evident that the Westwood and Schoolcraft intersection seemed to be a hot spot for crash incidents. So after further investigation, it turned out to be a high volume of turning movement incidents. As you can see here, there is no dedicated left-hand turn lane from Schoolcraft onto Westwood, and with south of Schoolcraft being primarily industrialized, there's a lot of turning movements in that intersection. And since the Schoolcraft and Westwood intersection is going to be our primary source for our material reaching our site, we decided to upgrade that intersection. Here in the upgraded intersection, you can see that we actually have that dedicated left-hand turn lane, which we're hoping will eliminate all those turning movement issues. The nice thing here is there was 2 existing parking lanes on the north and south side of Schoolcraft, so what we were actually able to do was shift the through traffic into that parking lane through the intersection and back over to the traditional through lanes. The nice thing with this is there was no major reconstruction required for this, as in all this fit within the existing pavement, so all that would be needed to upgrade this intersection would actually just be restriping. Moving inward to the site, the transportation portion of this consists of the redesign of Granville Avenue and the parking lots and the loading docks. So starting with the parking lots, on the northwest side of the site, we have the larger parking lot, which is mainly for the manufacturing and skilled trade employees for the manufacturing space, while the southwest parking lot is primarily for the office employees. And on the far south side of the building, that is where our loading dock is, where we have truck chassis storage, where our raw materials are going to come in and be offloaded and brought into the facility. Using the calculated traffic count projection, I was able to use the nomographs to develop my pavement cross-section. According to the nomographs, I only needed 3.5-inch cross-section, but since we are in Wayne County requires a minimum of 6 inches of pavement. So I had to then manipulate what I calculated using nomographs to fit Wayne County standards. But I still utilized the existing 3.5-inch cross-section and used that for the parking lots on the west side. Here's a full cross-section from right-of-way to right-of-way of Granville Avenue. You can see here we have our 6-inch cross-section on our 21A. The road is 30 feet wide from face to curb, and the pavement of choice that we used was asphalt, the low-volume super pave. I'll now hand it up to Brian for construction.
Thank you, Zach. The construction update can be broken into 5 key points. The first being the scope management plan, the second being my logistics management plan, the third being my sustainability management plan, and then fourth, schedule, and lastly, cost. For my scope management plan, the first thing done was the entire team was taken out to the site for a thorough site investigation. This allowed everyone to have input on risks that they might see, and a risk register was created for the entire project. With this, we initially spent time in the city of Detroit gathering information on other site constraints. We're going to take a look at some of the site constraints right now. The first site constraint you're seeing right now is our setback requirements. As you can tell on the south side of the site, there is some easement that run through for both our combined sewer and our existing electric. Those cannot be moved. We've got our water on our site, our gas main on the site, our electric, as you can tell, there's one pole, so there's one existing light on the site. And then lastly, our existing combined sewer for the site. With most of the design complete, a logistics management plan was developed. There's 2 phases to this logistics management plan. The first phase involves traffic being allowed to flow through the site as we leave the road in place for most of the construction. Some key features of this plan consist of fencing the site in and maintaining almost all contractor items on the south side of the site, as there will be a guardhouse and a guard station there for the entire duration due to the neighborhood this construction is taking place in. For phase 2, we'll take a small section of Davison to ensure that we're able to tie in, and we'll be doing all of our road work. At this point, the building construction will be complete, and internal construction will continue. So the external shell will be done, internal construction, however, will continue at this time. For our LEED certification, we are considered a LEED certified building. We have 44 out of the possible 69 points. Some key features of our building is that it's a brownfield, so it's a site that they would like to see developed, and we have an extensive rainwater management plan from John. For the schedule, Microsoft Project was used to develop a critical path. From that, you can see some of the milestones here. Construction started in January. Most construction will wrap up in January. However, final completion isn't until March. This is due to finishing off any punch list items along with the amount of commissioning needed to go into the building for our LEED certification requirements. The total project cost is $10.9 million, of which 60% of this comes from our steel, our general conditions, and our internal building components. The final item created for this project was our cash flow diagram. This was generated once again also using Microsoft Project, As you can tell, at the beginning of construction, about $2 million is required up front before actual construction commences, and most months require less than $1 million worth of inflow for the construction to continue. Our two heaviest months of construction are in July and August. Thank you, Senior Design Venture Capital Fund, for your time, and we now open up the floor to any questions.
Are we ready?
So, if we could, advisory board members.
Ashley? Computer?
For Ashley, on the structural, you put jack trusses between the main frames of the other trusses. They're not carrying any load, so why do we need a jack truss there?
The jack truss is the one that's, the carrying trusses are going into the jack truss, so the jack truss is going to be carrying the most load. That's why it's spanning farther. It's 40-foot spacing in the center of the manufacturing building compared to the 20 feet on the outside.
Don't the purlins go from main frame, the main trusses, one to another, 40 feet long, the purlins?
They're 20 feet long.
All right, so they go in the opposite direction. Also, my question on I'm looking at the composite roof or the green roof. You're spanning 6'8" between the purlins?
Yes.
And is that, what's holding up all that soil and what holds all that load?
The steel deck. There's a steel deck that was designed for the manufacturing building.
But that'll hold all the dirt and
Yeah, it was
whatever's out
designed
there for
to
the green
hold
roof.
the weight of the green roof and the snow loads.
Okay. I had a question also for Aaron regarding that retaining wall. It looks like a pretty heavy-duty retaining wall for a 2-foot drop, but it also looks like you kind of designed it as a monolithic pour. Wouldn't you put a spread footing down and then maybe just a vertical wall to hold back that soil?
Sure. The main reason for having it such a large mass is because of the truck's weight that is very nearby on the soil, so that you're pushing it out. So it had to be designed for overturning and sliding.
Okay, thank you.
Aaron,
Question for you. Can you talk about some of the other deep foundation options you considered and looked at, and why ultimately you decided to do drilled shafts?
Okay. Well, shallow foundations were the first option looked at, and I actually analyzed 2 different depths, one in the sand layer above the water table, one in the clay below the water table. And the bearing capacity was fine for the sand layer, but it was that settlement that was too much to support the shallow foundations. So moving on to a deep foundation option, obviously the stronger clays were below 50 feet, and the real reason shafts are more of a better option than I thought piles was because you need that large area that the bell provides to gather as much end bearing resistance.
Okay. And also the question for transportation. How did you determine your easel counts in order to design your paving section, and what influence did the amount of truck traffic have on your easel values for your paving design?
See, what I did was I ended up looking at what the total easel count was, so I went and determined our total traffic, and then I kind of set different numbers, like a percentage. So I took a percentage of, I can't remember, so you want to go to the back actually of the calculations for that. So here on the left side of the screen, I assumed it would be 50% cars, 33% two-axle trucks, and then I assumed 17% tri-axle trucks, and then I went about developing my total ESO value that is there on the total bottom.
Great, thank you.
You had mentioned the neighborhood being an issue during construction. How are you planning to address the security of people working in the area when the construction is done? I don't know who's best to answer that question, but it's just, I wonder if that was in the site planning. Do you have security considerations?
The main security consideration that we looked at was actually lighting at this point. Fences were mentioned and brought up. It would be something that we would talk to the owner as to whether or not he'd like to see all of the parking lots fenced in. When speaking with them, they said during the day they did not have any major issues. However, at night it was not the best of area.
My next question is, in an assembly building such as this, there's a material handling issue. Did you plan for material handling in your structure? Through our structural engineer over here?
Can you elaborate?
Well, let's suggest in the manufacturing building, you often see bridge cranes that will move materials because you bring in raw materials on one side, you have a finished product going on the outside. And I'm just wondering, you have a fairly substantial roof framing system, and I'm wondering if your column or the roof framing is considering, crane load or material handling loads.
No. Towards the beginning of the design of the building, we considered a gantry crane, but it was ended up not designed for.
And my last question is, you mentioned water savings with the green roof. How did you calculate that, and what is the actual savings, and how did you get to that number of 6
From the water savings from the green roof was a concept that I originally heard about on campus at the 2015 Stormwater Summit. Lindsay Mobley gave a presentation about the greening of Detroit. One of the topics of that was expected drainage credits for commercial residential owners who disconnect or remove the volume of runoff water. So it's scheduled to be $750 per month per acre. So just the green roof being the single 1 acre feature that it is, the savings were generated from that, using information that Detroit Water and Sewage Department publishes.
Thank you.
Thank you.
First of all, great delivery, all 5 of the speakers, very nice. My question has to do with transportation. Zachary, how was the growth rate? What's the basis of your growth rate for your 20-year projection?
The basis of the growth rate was I took the existing 2015 data that I gathered off the SimCog website, and then I used the trip generated counter to determine how many trips daily would be to our site, and then I assumed a 2% growth every year on top of those numbers. So I started out with the base, and then I assumed it went up 2% every year.
So the 2% was not provided by SimCog, that was an assumption you made?
The 2% on the SimCog website showed that it was going up consistently 2% from the previous years on the website, so I just assumed we would continue on with that 2% growth rate.
Okay. The upgraded intersection at Schoolcraft and Westwood, I've got a couple questions about the geometrics of this intersection and how much study you did on the geometrics. What is the longest length of vehicle this intersection is designed for?
Currently, I have 68 feet worth of storage length, so I have it estimated as like roughly 3 cars or like a full-size semi-truck trailer would be able to be stored.
So 68 feet is the longest vehicle you
No, I'm sorry. I have 68 feet worth of storage. I'm saying that I have approximately 3 cars worth, so a 53-foot semi-truck trailer could fit in that turning lane.
Okay, so I'm interested in the turning radius. How long a vehicle did you design the turning radius for?
The turning radius, I actually did not adjust that. That was already set from what it was before. I'm not 100% sure off the top of my head what the existing radius is, but I can look into that. I just looked into trying to minimize the amount of impact on this intersection.
Okay. What is the posted speed limit for Schoolcraft Avenue? Do you know?
I believe in this section it was either 25 or 35.
Okay, so it's very low.
Mm-hmm.
Did you look at the rate of shift when you were shifting your through lanes over 6 feet to accommodate your center turn lane?
Yes, I looked in and used the equations with the posted speed to make sure that the shift wasn't too dramatic.
And is it based on a deflection, or did you use horizontal curves?
I used the horizontal curve.
I have one last question about the site layout. Were any of the turning radii looked at on site? I think there were overhead doors on the west side of the building as well as the south side of the building. And was the intent for the overhead doors on the south side for large trucks to enter and exit? I'm sorry, on the west side. Were large trucks expected to enter and exit from that door?
On the northwest side doors, that's more for the 26-foot chassis that come in on. So it was the radiuses were designed to fit the truck chassis that they use, and it also follows the standard that Wayne County has for industrial complex driveway approaches. So it was designed for the tow truck chassis. Those aren't meant for any larger vehicle than the chassis that they use.
Okay. And with a roughly 65-foot long vehicle in your performance area, are those radii in your oval? Will those accommodate?
Say their tow trucks are actually 26 feet long, and all of the radii in the performance track were designed to that radius from the geometric design book.
So the tow truck would never be carrying the low tower, the low.
Say on this design, they actually don't have the on the low loader. They don't actually have the bottom tow stinger. There's mainly just the bed, so it's just the whole length of the chassis that I had to be concerned with.
Okay. Thank you.
Hi, I had one question for the water resources. Jonathan, how did you arrive at a 2,000-gallon tank?
What I did was I used the American Water Works Association formula for the water flushes. So they recommended 2.2 gallon flush. So I took that and times it by the number of employees we can anticipate, which is 75. Used a factor of 2.5 flushes per day. And we came up with that size tank allowed for 56% of the water use to be made up. It is undersized to meet 100% of the water demand. So that was the methodology I went through to use, was to figure out the required amount of water that I would need for the employees to flush, and then size the tank accordingly for the surface area of the roof.
And how many days would that last?
The single tank?
How many, yes.
I don't know, I'll have to look into that. I don't know off the top of my head how, if the tank was full, how many days use the occupants could get out of it.
Okay, and I was also thinking the replenish rate.
Oh, well, that would depend on the intensity of the storm value. So when Urban Green calculated it, it used a variance of storms from 0 to 2.34 inches, which was our storm intensity value. And I don't know the answer though exactly to the replenish rate from an empty tank to full, or if there was no events from full to empty. I'd have to look into that information.
And then a question for you and the geotechnical engineer. The water table is at 6 feet. What keeps the tank in the ground?
Aaron came to me, and I'll elaborate on that, but one of the things he wanted to do was to be able to design an anti-buoyancy block. So I'd let him speak on it a little bit.
I did an analysis of the tank when it was empty to see if there was any major uplift forces that could heave it out of the ground, and the soil block above the tank kept it from being uplifted.
With the tank under full buoyancy?
Yes.
Oh, okay. Very good. Thank you.
first of all, I just want to commend all of you for such a great job. It's a big task to stand in front of everyone and to talk about your project, but the graphics and everything were just beautiful, and you guys did a wonderful job. But what I was curious about is, you had the green roof, you had the reuse tank, you had the biofiltration programs, and how much coordination did you have within your site development and your costs to see if these things were cost effective or not? Maybe discuss that a little bit.
In the long term for our client, are you asking how they would recoup the investment? I gotta say to that, I never calculated a final price. I know the prices that I was providing for the cost were per published prices per square foot of the system installed, but I don't know straight away their return on investment for just any one of those single items. I don't know if Ryan might be able to elaborate, but I know the information I provided him for pricing was just on a generic green roof. This is a square foot at these dimensions.
Can you, go ahead, I'm sorry. No. Oh, can you talk a little bit about your water quality and how you determined that it would meet that 80 parts per million for the total suspended solids?
How it would get removed?
Yeah.
What the Wayne County program requires is that you choose from a pre-selected, pre-manufactured system that's proven to capture hydrocarbons and suspended solids at the inlets. And then I didn't see an exact methodology to define that the biocells are providing that infiltration rate. They want you to show that your water goes through some soil medium that will hold those suspended solids. But at the inlets, it is required that you choose a pre-manufactured product that's proven to meet performance specifications from an outside party.
What were those again? Could you
the main one that they focus on is just that you can prove your system, your inlet is going to have a pre-manufactured system. I didn't see a particular set of guidelines that broke down how much of each particulate or contaminant had to be removed by the performance system itself within the method.
Okay. Well, thank you. Yeah, I was questioning, you said the water table was 6 feet deep, and it was hard for me to tell by your profile how deep your main collection system is and your storm drains. Did you look at that to see how deep the facility was with respect to the groundwater table, and if you required dewatering, or how you would constructability of that system would be?
No, I didn't across the whole board. We planned though that because of the 6 foot, we have our outlet invert is at 14.5 foot. So we would definitely encounter some sort of ground retention dewatering system while they were down there installing the system. Plan for all the connections to have a bituminous sealant on the pipes, so that way we won't have infiltration from the groundwater into the pipe itself. But there were no extensive plans that were researched for.
Did you have to do a construction estimate for the cost of the pipe and the installation of the storage collection system?
I didn't conduct that myself. No.
Yes, the cost estimate was done for the installation of the pipe. However, the dewatering cost was minimal due to the fact that I was not able to finalize calculating which parts are going to be above and which parts are below before this presentation. So there is a dewatering cost built into our general conditions. I'm not sure at this point whether or not it is enough for how much dewatering we're actually going to need.
The constructability of the work. Could you go to the storm drainage layout slide? I'm curious why there was one area where it seemed like you took the long way around to get to your collection system. And I just wondered what your thoughts were. Like in the very northwest corner.
What it was, the last component of the site layout that we could all come to agreement on as a team and to meet the academic requirements of the program was the test track. It was in debate in terms of the geometrics and the ergonomics of it until the very end. So when this pipe profile was put down, we did take the long way to get to the outfall. But it was just due to the fact that we knew we were going to have some sort of depressed road feature in there with a pit and a wall. We weren't sure yet on the location or the exact depth of it to try and go under it or around it. So we just chose to go a straightforward way that wouldn't interfere with the final design of the test track at all.
Yeah, I was just curious, what was your biggest challenge, you think, working with the different regulatory agencies and the, as far as the stormwater goes? In your outfall, the CSO line?
The biggest constraint I had was to minimize the water that I wanted to minimize the amount of water that went into the system at all. Because I had 4.2 acres total to work with, and by the time I got to the site, 70% of it was already some impervious surface to begin with. And I'm only allowed a 0.15 cubic foot per second release rate from the site per acre. It comes to 0.62 cubic feet per second for the entire site. I had to just use as many methods as I could to promote bioinfiltration to keep that water out of the hard pipe system. For sure, that was the single hardest element.
Yeah, very good. Thank you.
Thank you.
And any other advisory board members who have questions? I have one question.
That's okay. Regarding the depressed section in the test track, how is that going to be drained?
We actually talked about that recently. There was no final drain put in there, but as it is, we sort of had fun kicking around the idea that that's where our client could test the water resilience of their controllers or their different record components come springtime when they have full ice melt, full flood, so it was holding water. It's true though that sometimes people do find their way into bodies of water, so maybe the wrecker operators could get some cold water training too. So as it sits right now, there is no water drainage feature for the pit itself.
I have a question on the cash flow.
Yes.
What activities on site or material and equipment deliveries are causing the July and August cash flow bars to be about triple June or September?
During this time, we have most of the major shell construction is taking place. So all of our steel erection is happening, all foundations are going down, and along with our concrete floor is going down at that point in time. So those are the three main activities that are taking place in August, or in July and August, that are requiring a heavy amount of capital flow.
I would suggest that maybe the schedule needs to be looked at, because they have foundation, steel, and slab going in an 8-week or 9-week period. Might need some adjustment.
I will look into that.
Is that for advisory board members? All faculty?
So I have some question for the water resources person. Can you pull up slide 33? So you have decided on 7 sub-catchment areas, and you also mentioned that you're using the rational method. What factors have you taken in consideration in sizing this sub-catchment? Like catchment 1 is extremely large compared to relatively to the others. So how was that decided?
The catchments were divided amongst, firstly, the parking lots were divided to have easy drainage to the drainage structures. So that's why catchment areas 3, 4, 6, and 7 are individual amongst themselves, just because they go to a hard structure itself. Catchment 1, when modeled in StormCAD, I just put in the entire building surface because as a worst case scenario, I figured I would make as a large proportion of the surfaces of the entire area impervious for modeling. So the entire system was sized as though I had almost no bioinfiltration, low impact developments on the site. That way I felt confident when I take my 1 acre plus roof and model it, re-roof, and pull some of that volume away, that the system will still be efficient and function. So that's how I went about doing it. Catchment 5 was just left individually incised to a single catch basin shown on the west side of the road there. As it's 0.54 acres, it is sufficient to roll to a single catch basin, to flow to a single catch basin towards the outlet.
Okay, I need to stop you right there. So, whether it's hand calculation using rational method or stump calc, both methods uses rational formula. So what are the parameters within rational formula?
The flow calculation Q is dependent upon the coefficient of runoff C, the intensity of the storm I, and the area of the catchment A. So it's rational method calculation Q equals CIA. Every catchment area has an individual coefficient for runoff, asphalt being different from grass. So you apply the requisite coefficient to the area, and then you determine the intensity of the storm based on the time of concentration, which for this site would be for any site would be the longest overland time of flow from the furthest area to the point of study, which would be our outfall. Those parameters were used to model and storm data.
So what is, at the outflow, what is the total stormwater discharge like?
It's 0.62 cubic feet per second.
Okay, 0.62. Now, in most counties, you're restricted to 0.15 CFS per acre.
Mm-hmm.
Are you above or below?
We're below.
You're below?
Yeah, we sized the outlet to be below.
Could you pull up slide 35, please? Okay, so this is a profile, the hydraulic grade line profile, the hydraulics of the flow. I noticed that, so there were questions earlier about your 6-foot water table. So I can see here that the middle section is extremely steep. How was that decided?
It had to, I had to drop down in elevation to go below the existing combined sewer loop that crosses our site. So that's why we had to dramatically drop down in elevation.
So what kind of flow, so I'll give you some words to pick from. So that steep section, is the flow turbulent? Is the flow subcritical? Or is it supercritical?
There's going to be a turbulent flow through there that I do believe was subcritical during the analysis. But right now, as it relates, I don't know for this particular section.
So if you look closely where the manholes are, am I seeing hydraulic jumps occurring?
You are. Right at the two lowest, we are seeing hydraulic jumps. That's where the lines pop back up.
So before the jump, are the flows subcritical or supercritical?
They'll be supercritical before they jump, and then it'll slow down.
Okay, thank you.